We are conducting the collection and processing of radioactive accumulated water at Fukushima Daiichi Nuclear Power Plant. Last week we explained how the highly concentrated contaminated water is processed in the system. Today we will explain how desalination is conducted after the above processing. The outline of the water processing is as explained in the last session. Today we will explain desalination mechanism using the desalination facility, the RO membrane, and evaporative concentration. We have to conduct desalination of highly concentrated contaminated water after removing radioactive materials such as cesium by using the first cesium absorption apparatus, second cesium adsorption apparatus, and the decontamination facility. We are using two methods to process the water. The first, we are conducting water processing by reusing the desalinated water to the reactor and storing the concentrated salt water in the tanks. The outline of components is as described in this table. Today we will explain about the upper area encircled by the dotted line. First, accumulated water is collected to the SPT-B tanks and desalinated by the RO membrane. The water is divided into two categories. One type of water is to be transferred to the buffer tanks and used as processed water. The other is for temporary storage as concentrated salt water. This salt water is further divided into two categories by using evaporative concentration apparatus. One is concentrated waste liquid, the other is used as fresh water. Since this looped system is already completed, we can cover all water injection into the reactor at the power station with this processed water. Next, we will introduce the mechanism of desalination by using the RO membrane. Basically, this is the desalination plant by the RO membrane system. This is very popular as a facility for transforming seawater into fresh water. Generally, fresh water is delivered to the seawater side to equalize the density of salt when we separate the seawater and fresh water with the RO membrane. The fresh water penetrates to the seawater side till the density of salt in the seawater side reaches a certain level. Meanwhile, it is the RO membrane's job to reverse the above function. To reverse the function, the mechanism is that of pressing the seawater side to transfer only fresh water to the left side, the freshwater side. Accordingly, the rate of production of fresh water to concentrated salt water is at approximately 4:6. We can produce approximately 400 cc's of fresh water from 1 liter of contaminated water. Today, 4 types of desalination plants have been installed. The processing capacity of RO-1A is 270 cubic meters per day. RO-1B is 300 cubic meters per day, and RO-23 is 1200 cubic meters per day. RO-1A and B were manufactured by ACE Water Treatment, and RO-2 and RO-3 were manufactured by Hitachi. In addition, we are primarily operating RO-23. Today we are operating RO-3. This is the outline drawing of the desalination plant shown by the picture. The left picture shows the RO membrane module. The fresh water penetrates from the seawater side via saltwater injection to the point that looks like a white pipe. After that, starting from the right-hand picture, the water is divided into the concentrated salt water and the processing tanks after passing through the filtering apparatus and RO membrane for desalination. Although we can increase the processing capacity to 1,800 cubic meters per day when we connect 4 plants, we are adjusting the processing capacity in consideration of the amount of processed water reused in the power plant and the status of concentrated salt water storage tanks. We have another type of salt content removal system. That is an evaporative concentration system which is similar to making a salt farm. The system makes salt containing evaporated water and extracts fresh water. The condensate salt water remains as condensate wastewater. Water treated through the RO membrane is divided into fresh water comprised of 40% of the total treated water, and the condensate salt water is comprised of 60% of the total treated water. The condensate salt water is further evaporated by the evaporative concentration system, and then the freshwater condensate wastewater will be separated. The condensate wastewater will be safely stored in the power station. Currently, 8 concentration systems have been installed in the power station. The list of the systems is shown in the right table. Although there is some variation in the treated volume, the systems, including the recently installed 3A, 3B, and 3C manufactured by Toshiba, have been operated. The system treats 250 cubic meters per day. As you can see the freshwater rate, fresh water can be extracted at 70% from the total amount of treated water. This contributes to the production of fresh water as well as the reduction of condensate wastewater. This slide shows the construction of the evaporative concentration system 2A. You can see that there is a boiler horizontally installed in the center. This heats water and extracts salt. The system can treat a maximum of 750 cubic meters per day. However, we operate considering the balance of produced fresh water and stocked condensate salt water like the RO membrane operation. We will explain the actual construction schedule. At first, we started to construct the RO membrane. At the beginning, we operated the water treatment system at 1A, 1B, and number 2. After August, we completed the number 3 RO membrane. As a result, we were able to secure enough treatment capacity. After that, we continuously implemented the construction work of the system, dividing it into a first phase and a second phase. This is the construction schedule we have implemented for the reduction of condensate salt water. The last slide shows the capacity of salt removal. The RO membrane system and the evaporative concentration system have a capacity to reduce chloride ion to 0.025% and 0.0001% respectively. At the beginning of the operation, chloride ion, which exceeds 10,000 ppm, was treated. Presently, approximately 4,000 ppm chloride ions have been treated. On the other hand, the density of the chloride ion treated by the water desalinations has been controlled to under approximately 50 ppm. We understand the treated water can be used as fresh water. This is the water treatment results as of today. This is the record as of the end of October. We have produced 60,000 cubic meters of fresh water. As for the operation of the system, since we have operated considering the balance of fresh water production and condensate salt water, we have not operated continuously. However, overall, steady treatment has been implemented. Today, we explained the mechanism of water desalinations and operation records.